video, we solved one problem, and then let's see how we can tackle this one. This one says 56 grams of nitrogen and 96 grams of oxygen are mixed in 2.0 liter container at 300 watts Kelvin. Then calculate the partial pressure of each gas and the total pressure. So solution. Now they gave us the mass of nitrogen, N2, the mass is 56 grams, O2, that's your oxygen, is 96 grams, volume of container is equal to 2.0 dm cube, same thing as liter. Then the temperature is equal to 300 watts Kelvin. So they said we should calculate the partial pressure of what? Each gas. Now recall that partial pressure is equal to the mole fraction times P total. That's times the total pressure. But how do we get the mole fraction now, since they gave us this thing in gram? And remember that mole is equal to mass all over what? Molar mass. This implies that let's find the number of moles of nitrogen. Number of moles for N2 will now be the mass, which is 56, all over molar mass of nitrogen. This is nitrogen, is the atomic, so this is 28. So 56 by 28, what are we going to get? 56 times by 28. Sorry, divided by 28. 56 divided by 28. This will give us 2. So the number of moles for N2 is equal to 2. Then the same thing applicable to oxygen. That of oxygen will now be equal to 96 all over what? Oxygen is also diatomic, so 16 times 2, which is 96. And when we do that, we're going to get 3 moles. 3 moles. So total number of moles will now be equal to 3 plus 2, which is equal to what? 5 what? Moles. So mole fraction of oxygen, let's use the notation O2, that's mole fraction of oxygen, will now be number of moles of oxygen, which is 3 all over 5, and the mole fraction will be equal to what? This is 0.6. The mole fraction of nitrogen is equal to the number of moles of nitrogen, which is 2 moles, that is 2 all over what? All over 5, and 2 over 5 is going to give us 0.4. Recall that when I add these 2 mole fractions, it's going to give me 1. Let's check. 0.6 plus 0.4 is equal to what? 1. This means that our mole fractions are what? Correct. So anytime you get the mole fractions, add them to see whether it will give you 1 before you progress. Now I say we should calculate the partial pressure of each gas. So partial pressure of oxygen will now be the mole fraction of oxygen, which is 0.2, that is XO2, which is what? 0.2 times our what? The P total. Times the P total. But the problem now is that we don't have our P total. Remember, times P total, but we don't have our P total. Just look at this. 0.6, which is the what? The mole fraction of oxygen multiplied by P total, but we don't have our P total. But fortunately to us, we have the total number of moles. So we use ideal gas equation, which is that PV is equal to what? nRT. And now, which is the total number of moles, is equal to what? 5 what? Moles. So now, to get the P total will now be equal to the volume of the container. Volume of container is 2.0. So this will give us the number of moles, 5, times gas constant, 0.08206, yes, multiplied by the temperature given to us. Temperature is 300 Kelvin, times by 300 divided by the volume of the container is 2.0. So P total, when we punch our calculator, we're gonna get 2 cancel here, 1 here will give us 150. So that 150 times 5 times 0.08206, and this will give us 61.5 watt. Let's use 51.5 ATM. Yeah, since we are using the ideal gas, so this should be ATM because of the unit of our gas, molar gas constant. So that's why I have this P total. So we can now go and then substitute the value of P total to get our partial watt pressure. So now we can now get that the partial pressure of oxygen will now be equal to what? 0.6 times 61.5. So the partial pressure now will now be what? 6.0 times 61.5. This will give us 36.9 watts ATM. Now, also, we can as well calculate that of nitrogen by referring back to the mole fraction of nitrogen, which is 0.4. So that will give us 0.4 times the total pressure, which is 61.5. So Pn2 is equal to 0.4 times 61.5. This will give us 24.6 ATM. Remember that P total will be equal to Pn2 plus partial pressure of oxygen. So let's check whether we're correct. That is 36.9 plus 24.6 will give us 61.5. So let's check. 36.9 plus 24.6. Yeah, when you punch, it's going to give us what? The same thing. So we've calculated the total pressure. That's one thing they said we should calculate. So we should calculate the total pressure. We've done that. Calculate the partial pressure. We've done that. And as well, partial pressure of what? Oxygen. Remember, this should be PO2. Also done that. This is PO2. Partial pressure of oxygen. So let's go back to what we did initially. First of all, we had to calculate the number of moles by using mass over molar mass. Mass of nitrogen is 56. We did 56 over 28, and that was how we got the number of moles to be 2. Also, for oxygen, we have to get the number of moles since the mass is given. If you recall back in the last video we did, we talked about situations where they will give us the mass. We have to convert and get our mole, or use the formula to get the mole. That's what we did. And then we have to sum to get the total number of moles inside this very container, and we get it to be 5 moles, and hence we now calculated the mole ratios. But we need to get our total pressure. And what did we do to get the total pressure? We used the ideal gas equation, and we arrived at this, and then we now solved, and then we got our partial pressures. This was just as a check to know whether we are correct. That was what we did. That was exactly what we did. So